Hey everyone, my name is Andrew Block. I'm a distinguished architect at Red Hat and a maintainer on the ORAS project. Just going to talk to you for a few moments just to speak about how we handle multi-architect images and distributing them using ORAS. Now, how many of you, show of hands, have used ORAS or know of ORAS? Well, basically, it is a CLI and set of binaries for managing OCI artifacts. OCI artifacts is a space that I have been very interested in for the last several years, especially when it comes to a lot of the new cloud-native patterns that have been coming up to speed in the last few years. It is really starting to take hold of why we're able to leverage a lot of the same technologies that we've used over the course of the last decade in cloud-native for new ways of managing assets in container registries. Now, how many of you didn't know you could actually store items other than container images inside registries? The best part about that means that you can take an advantage of a lot of the same tools that we've leveraged and built over the course of the last decade in a new way. So, what is ORAS? ORAS is a sandbox project inside the CNCF. It allows you to distribute artifacts in OCI registries. It also allows you to manage them, which means you can manipulate the artifacts after they've been published, as well as everything you need to do to actually put them into a registry. It allows you to use it as a CLI, which the majority of our users end up using, or as part of an SDK. I'm actually speaking at the next, literally right after this, at ArgoCon, talking about how we integrated ORAS inside Argo CD to be able to then start leveraging OCI artifacts and OCI images within Argo CD. It also has a number of SDK libraries in different languages, everything from Java, Golang, Rust, everything's out there. It's really key you can use it. It's also, ORAS is compatible with many different popular registries inside the community, everything from Docker Hub, Quay, Zot, Harbor, all are compatible with ORAS. And many organizations have really started to adopt and implement ORAS inside their own tools, workflows, and processes. Now, today's little quick talk is going to talk about multi-platform images. A multi-platform image means that you can distribute a single image or artifact and have it be compatible with multiple architectures. So I'm running a M1 Mac, which means I can run the image on my machine or run it on a traditional AMD 64-based machine. It allows you to then utilize the creation of both the OCI image and artifact format if we need to. We can support air-gapped environments. That's one of the better parts of ORAS that a lot of organizations are using. I know, like Czar from Defense Unicorns. I saw one of the guys from Defense Unicorns as I was walking up here. They've used a lot of tools and created tools for disconnected air-gapped environments. You can use ORAS to pull in artifacts and resources into those environments and push them to your local environment. You can customize the OCI artifact. You can add annotations, other metadata that you can then query and then be able to process against it. And then finally, you're able to attach resources to images. So if you think about how we're securing our supply chain, you can add certain artifacts like signatures, SBoMs to your artifacts to really understand the provenance of your images, and so in a multi-architecture format. So let's just do a quick demo of how we would go ahead and use ORAS to actually build a multi-platform artifact. So the first thing we're going to do is we're going to take a look at all the different tags we have in our local OCI layer. We're going to create an OCI multi-arc image using the ORAS manifest index. This allows us to take an artifact that was created in both AMD 64 and ARM64 and be able to create an artifact manifest. How many knows what a manifest is? A manifest list allows us to declare multiple architectures inside a single reference. So I can go to my image latest, for example, Quay.io/ablock my image latest, and go ahead and have it be compatible with OCI format. We can then go ahead and take the image that was currently available to us and push it to a registry. Right now it's running locally, or at least stored locally. We're going to push it to the remote registry and have it be available to us. And then we can actually now go into GitHub packages and see that both versions are available for our consumption by our users. Nice and simple. And the way we can make it secure is, as I mentioned earlier, we can then attach references to it. This is an example of how we can go ahead and reference an SBoM, signatures, etc., on a multi-architect image using ORAS. 5 minutes goes fast. I thank you for your time this morning, and thank you.